Hello everyone and welcome back to our channel Quaint. So today's topic of discussion is so interesting. We are talking about self-healing metals and medical implants. You know, medical implants are made of metals such as stents are there, then orthopedic screws are there, then spinal rods are there. All these things are made of metals, and we are talking about self-healing metals. That means, you know, when skin is cut, it heals automatically. The healing process is automatic when the skin is cut. So similarly, we are talking about self-healing metals. That means in case of metals, what happens? Cracks form. There is a formation of cracks. So what is the requirement? Say, medical implants are made of metals and cracks have already formed. So what is the requirement? Requirement is corrective surgery. That is the requirement. Corrective surgery is required. And you know, corrective surgery that is not good for patient safety. Corrective surgery that is not good for patient safety, that is not due. So scientists, especially I am talking about MIT in US and the Max Planck Institute in Germany, they are actually conducting their research work in this field. They are working on smart materials, more specifically self-healing metals. So medical implants, this was just an example. So many things are there. So many, in case of aerospace industry, in case of many things, smart materials are required. And especially we are talking about here self-healing metals. So at the heart of this ability, what is there? There is something which is called here shape memory alloys and nano-engineered microstructures that respond to external stimuli like what? Like temperature or strain. These are what? Temperature, strain. These are external stimuli. So these things, shape memory alloys and nano-engineered microstructures, they respond to such external stimuli. So what happens? Why they are responding? They are actually nano-engineered. Okay, those things are not found in nature. Like nitinol, that is one example. Okay, those things are nano-engineered. Reversible process occurs. If there is a deformation in that material, then in that case, the process is reversible. That means when cracks are formed, in those materials, cracks are closed. Cracks are closed, and that is the requirement. And that process is actually automatic. Okay, so actually this concept are used. So that means these are what? These are specially designed microstructures that store elastic energy. Okay, or are embedded with nanocapsules. And when triggered, say for example, temperature or strain, when triggered by something, for example, temperature and strain, then those micro cracks are repaired. Means those micro cracks repair themselves by using that technology. So this is what? This is actually the ability of self-healing metals. I'll make a separate video to discuss in detail about self-healing metals, but in this video we are talking about medical implants. What is the benefit? Why scientists are thinking about this problem? They are trying to use, means they are exploring ways to use self-healing metals in the field of medical implants. But this has not become yet possible. This means researchers are still working on this, because for those smart materials or for those self-healing metals, lab-controlled environments are required. Lab-controlled environments, that means high vacuum or precise heat sources are required. Okay, and one more thing is that all these things need to be integrated with those medical implants or wherever those metals you want to use. Those things need to be integrated. But since at present lab environments, highly controlled lab environments are required. So that's why more research is required in the same field. And I have mentioned here only two institutes, MIT in US and that the Max Planck Institute in Germany. Maybe there are more research centers who are working on the same thing. So many things are there. So this is a combination of actually frontier of physics and material science. And if I say frontier of physics, more specifically it is actually solid state physics, which involves actually so many things like diffusion processes are there, then martensitic transformation, that is also there. Okay, so many things are there. Anyway, so this was all about it, today's topic, and this is the end of this video. So that means we are going to get not only tough or strong materials or metals, we are going to get smart metals in near future. Anyway, this was all about today's topic, and this is the end of this video. Thanks for watching.